Morning, students. So the topic for discussion today will be the different types of insulators used in the transmission line. So what do you mean by insulators? So you might have from in your lower classes, you might have studied about conductors, insulators, right? So insulator means it actually provides a protection. So it provides a protection from the high current. So when current is flowing, when a current is normally flowing through a conductor, we also provide an insulation for that, right? Because if it touches the naked hand or something, it can be very harmful. So insulators are actually protection devices. So protection from electric current or abnormal electric current. So abnormal electric current can occur in terms of fault. So just understand that there is a transmission line and it has insulators, and insulators are used as a protection from fault. Fault means like when something happens and high current comes, we say it's a fault. We say it's a fault in the transformer, or we say it's a fault in that electric post. Something happened. So in such cases, we actually need a kind of protection, and for that we use the insulators. Okay, so like for your better understanding, an electrical insulator is a material whose internal electric charges do not flow freely. So what happens is in an electrical insulator, the electric charges, they are not allowed to flow freely, and therefore does not conduct an electric current under the influence of an electric field. See, so that does not allow the flow of electric current. That they don't allow the flow freely. Okay, so something called a perfect insulator does not exist. It is that it gives an overall protection. That's it. So regarding insulators means glass, paper, Teflon, they all have high resistivity and they are very good electrical insulators. So they should have high resistivity. Okay, and so how we use the insulators? So insulators are used in electrical equipment. Already I told during the first slide, they are used in the electrical equipment to support and separate electrical conductors without allowing current through themselves, right? So if you touch, like, you should not touch, but still we will not get an electric shock if you have an insulator, right? So it protects the equipment and gives a support also. Okay. And now we will see the different types of insulators. So there are several types of insulators, but the most common one which you should know and which you can see if you go outside and if you see an electric post, electric line, or if you have been to a substation, so these pictures you might have seen. These pictures you might have seen in your daily life when you go outside or when you are sitting in the backside of the car, and if you look outside, these things you might have seen. At least some of you might have seen. So now we will see what they are and what they do. Okay. So the main types of insulators are pin insulators, suspension insulators, strain insulators, and shackle insulators. There are many other types, but these four are very important. They are the basic ones. Okay, this is the pin insulator. I think you might have seen this picture. Not just in picture. In your real life also, you might have seen this. If you haven't seen, next time when you go outside, do watch them. Or maybe from your window also you can see. So the pin insulator consists of a non-conducting material, such as it can be porcelain, glass, plastic, polymer, or wood. So what's the property common to all of them? We have seen that they should have high resistivity. Then only they will become good insulating material. Okay, as the name suggests. So now we will focus on pin insulator in detail. So as the name suggests, pin insulator is secured to the cross arm on the pole. That is, it is pinned to the cross arm on the pole. Next slide, you have the figure, or else I will show you now itself. See, this is the pin insulator, and it is pinned. It is pinned to the cross arm of the pole, and there is a groove on the upper end of the insulator for housing the conductor. See, this is the groove for the conductor. See, this is, we should enclose or we should house the conductor. The conductor passes through this groove and is bound by the annealed wire of the same material as the conductor. So the conductor passes through this groove and it is bound by the same material. Okay. Pin type insulators are used for, so now this is the, as a student studying this for the first time, what you should gain from this lecture is you should understand what is the voltage range. So pin type insulators are used for transmission and distribution of electrical power at a voltage up to 33 kilowatt. So you know the voltage classifications, like voltage ranges 11 kV will be there, 22 kV. So here up to 33 kV in a transmission line, if we have for protection, we use a pin insulator. We need it's not advisable to use it beyond 33 kilowatt because more the it is too bulky and it will become uneconomical. So it's better we don't use beyond 33 kilowatt. So up to 33 kilowatt pin type insulator. So you have that figure in your mind and it will be pinned and it will pin to the groove. There will be a groove will be there and it will be pinned to the cross arm on the pole. This is the one. The conductor will be going here. Okay. So see, this is the groove. So it's better and it is advisable to draw these figures in your exam so that you will get, the examiner will give you full marks. So this is the figure. This is the pin type insulator. Okay. Now the second one is suspension insulator. They are suspended. So this is a glass suspension insulator. Insulator is made up of glass. This is another type here. Okay. So for high voltage, just you can imagine, I'm going in a chronological order only. So up to 33 we use pin insulators, and for high voltage, this is the most important. So for high voltages, it is greater than 33 kilowatt. It is a usual practice to use suspension type insulators. See, this is the suspension type insulators, which consists of a number of porcelain discs. So in the previous slide, we have the figure from glass also. So here it says it consists of number of porcelain discs connected in series by metal links in the form of strings. It forms strings. So later you will be studying about string efficiency and all. So here they are metal links used to connect the porcelain disc, forming the this suspension insulator. So what we are doing is the conductor is suspended at the bottom end of this string, while the other end of the string is secured to the cross arm of the tower. See, the conductor, it will be suspended at the bottom end of the string. See, this figure explains everything. Conductor is suspended at the bottom of the end of the string and it is secured to the cross arm of the tower. Okay. So electric towers also you might have seen. Outside fields and all, you have electric towers also. So each unit or disc is designed for low voltage. So here they have number of discs and each disc will be 11 kV. So and according to the voltage range. So if it is 44 kV, we take four discs. That is 11 into 4 will give you 44. So problem that you have to study your numerical problems based on this. So you will have better understanding when you do the numerical problems. How the efficiency we calculate, how many discs we use, such things you have the problem. So theoretical understanding is like the number of discs in series would obviously depend upon the working voltage, as I told you now. For instance, one example I am saying, if the working voltage is 66 kV, then 6 discs in series will be provided on the string. That's it. The string will have 66, 11 into 6, 66. Okay, and this is the figure, suspension insulator. And now we will move on to the strain insulator. So we have the suspension insulator, pin insulator. So sorry. So all these insulators, from the name itself, you have what it is. So this also, just think about from the name, what idea you are getting. And now listen to my lecture. So when there is a dead end of the line or there is a corner or sharp curve, the line is subjected to greater tension. You see, we have a transmission line going straight way, and at some point we cannot take it all straight, right? There will be bends, there will be turnings and all. And when a river comes, we should if the river is too much long, means it should go too much length. Such problems are there. When tension in the line is exceeding at long reverse spans or two or more strings are used in parallel, that condition, the tension will be very high. So in order to relieve the line of excessive tension, strain insulators are used. And for low voltages, which is less than 11 kV, shackle insulators are used as strain insulators. So shackle insulators we will be seeing in the next slides only. So however, for high voltage transmission line, you see, for high voltage, we use the strain insulators. Why we are using? Because strain insulators, it helps in reducing the tension in the transmission line. How the tension occurs? Because the transmission line cannot be straight always. So at times it will have bends and corner or sharp curves, then the line is subjected to greater tension. And the disc of the strain insulators are used in vertical plane. See, this is the strain insulator. All these things you can find if you go outside and look at the electric post and all. This is the strain insulator. See the transmission line of the conductor is coming, and you at the corner or whatever it is, we call it corner or sharp curve, we are using the strain insulator, which helps in reducing the tension in the conductor. Okay. And now, and one more thing regarding shackle insulator means, if it is less than 11 kV, that is low voltage, means we use less than 11 kV. We use shackle insulator as a strain insulator. For reducing tension, we use shackle insulator. So, you see, the same is mentioned here. In early days, the shackle insulators we have mentioned as strain insulators, but nowadays they are frequently used for low voltage distribution lines. Such insulators can be used either in a horizontal position or in a vertical position. They can be directly fixed to the board. So the insulator which can be used both in a horizontal and vertical position is the shackle insulator. They can be directly fixed to the board with a bolt or to the cross arm. Okay. And this is the shackle insulator. We have the electric pole here. Then they are bolted. This is the shackle insulator. This is a D-strap. You see, this is a D-strap. Shackle insulator, the bolt, and this is how it is connected. Directly fixed to the pole with the bolt or to the cross arm. It is seen in the figures. So these are the four insulators. So now you understood what is an insulator, why we use an insulator, then the different types of insulators, their figure, why, which voltage range we are using, all these things. I hope everything is clear for you. In case of doubt, I shall clear that for you. Okay, so this is the types of insulators, and so this figure shows all the insulators we have studied. I think everything is there. Yeah, insulators. So what is an insulator? Maybe you can get 1 mark or 2 mark question. Then types of insulators. In terms of electric power system, that is electric transmission system. Okay. Okay. Thank you.